Wait, have you started it? Okay, well, my name is Dr. Kimbler, and I will show the world what the Doppler effect is. And these girls are going to help me, whether they like it or not. And if they don't help me, I'll turn them into too late! Demonstrate the role of the Doppler effect in 3 different waveforms: water, sound, and light. And now they're going to explain the Doppler effect.
Most of you are probably wondering what the Doppler effect is. For those who don't know, Austrian physicist Christian Doppler proposed the Doppler effect in 1842. The Doppler effect is an observed change in the frequency of a wave when it moves. It is an increase or decrease in the frequency of water, sound, or light wave as the source moves closer to the observer or receiver. For example, in a water wave, the Doppler effect occurs when the source moves toward the object. The sound wave is slightly different. For instance, the Doppler effect occurs when the receiver hears the source getting closer. As for light, it is an electromagnetic wave that can be visible to a human eye. A human eye! Here we are going to go more into depth with the Doppler effect really is. Embrace yourselves for what you are going to see!
We are going to start talking about the Doppler effect in water waves. The Doppler effect is a frequency change in the water as a source travels to the observer. Now we are going to demonstrate how the water waves change when the Doppler effect takes place.
If we had a moving object in the water, it would produce concentric waves. But in this case, we will be moving the object ourselves. As the source shifts to point B, the waves behind the object have a lower frequency because of the distance it takes to reach to the point. As for the waves in front of the object, their frequency increases the distance from one wave to the other, and the other one is shorter. Therefore, the shift in the frequency of the object to point B is called the Doppler effect. Not only does the Doppler effect occur in water waves, but also in sound waves.
Okay, so now we're going to explain the Doppler effect as it concerns sound waves. The change in pitch due to the motion of the source is the Doppler effect.
For example, the noise of an ambulance siren. When you are standing outside on the sidewalk and an ambulance is approaching, its pitch is higher than when it passes you.
That is, the sound waves that approach the listener have a higher frequency than the waves that reach the listener after the ambulance has passed.
Another example is the sound of a car honk. The same thing happens when a car is honking and it passes the listener. The sound is higher when it passes you, but starts to vanish as it starts to get further away. Once again, there are fewer sound waves reaching the listener.
Components. The main components would be the wavelength and the amplitude. Aside from those two, there are a couple of other components, which are the node, the trough, crest, the direction from where the energy comes from to make the light wave, and finally the direction from where the oscillation comes from.
The Doppler effect takes place when the source of light moves the wavelengths in front of it, making the wavelengths shorter than the ones behind it.
There are many different ways of creating or seeing a light wave, but our eyes can only perceive to see unpolarized light, and we struggle to tell the difference in polarized. Such unpolarized light can consist of fluorescent lamps, candle flame, or incandescent lamp. We can also see polarized light. A perfect example of an object transmitting light is a pair of sunglasses that emit us to show how much light we can see.
The effect is a case of color instead of a case of pitch. The light in motion moves the wavelengths. If a source of light was moving away from the receiver would see the larger values in motion. But if a source of light was moving towards the receiver would view the smaller values. The large wavelengths that could be viewed as the source of light moves away from the receiver is known as a redshift. But the short wavelengths that could be viewed as light moves towards a receiver is known as a blue shift.
And these are the different types of waves in which the Doppler effect can take place.
Dr. Kimbler, we've done as you wish, and now it's time for you to zap us back into our human bodies. Please, we beg of you.